this session, we will be discussing how a single layer perceptron will process the given data. So here in this example, we have the activation function f of net equals 1 if the net value is greater than 0, and it should be 0 otherwise. Right? This is the activation function for the particular perceptron which is defined. And here we are going to use an OR gate. You can use any gate, but it is specified as we have to use OR gate. And the weights for W1 and W2 is specified as 0.2, and bias is minus 0.3, and the learning rate is 0.1. Right. Now the learning rule is, if I want to find the new weights, it should be weights plus the learning rate into t minus y into xi. And if I want to calculate the new bias value, then the old bias value plus the learning rate into t minus y. So when we will apply this learning rule, when our function, activation function, will give a false perception, a false result when we compute it, then the weight should be adjusted, right? So in that case, we have to find the new weights and new bias. We have to adjust the weights in order to make the machine to learn it and correct it in the proper way, so that it can classify it correctly. So the misclassified output should be checked, and if it is misclassified actually, which is contradicted to the already defined truth table of OR gate, then we have to adjust the weights and modify the values and calculate based on the learning rule in order to make it as a right classification process. So let's see an example here. In OR gate, what is the truth table we have? If it is 0, 0, right, it should be 0. If it is 0 and 1, the actual truth table, we should get value 1. If it is 1, 0, we have to get 1. If it is 1, 1, we have to get 1. Right? Any 1 is placed here, then the truth table of R will give 1. If both are 0, then the OR gate will give you 0. This is the truth table for the OR gate, which is already predefined, we know very well. So let's start with a single layer perceptron, step 1. So in step 1, what is the value we have? 0, 0. We will check whether our learning process is classifying it correctly. First we have to find net, so that if the net value is greater than or equal 0, we will fix with 1, or else we will fix with 0. So first we should know net value. So we will fix the net value first. What is the formula that we have to use here? Net is nothing but W1 x1 plus W2 x2 plus b. This is the net function which is used for calculating it. We have W1 value. What is the W1 value we have here? It is 0.2, and W2 is also 0.2. We will directly apply it. 0.2 into, what is the value of x1 here? x1 is 0, x2 is 0. 0 plus W2 is also 0, 2, and x2 is 0. Plus, what is the bias value we have? We have the bias value 0.3, which is already given here. So we will directly use the given values. So now 0 plus 0 minus 0.3, it is nothing but minus 0.3. So now the net value is minus 0.3. Here we will check if the net value is greater than or equal 0. Since we are having negative value, this case fails. So obviously it will move to the otherwise case. Otherwise case, the value should be 0. So I am going to give value as 0. Right. So now check the truth table. If 0 and 0, then the truth table should give 0. So similarly, I have got 0 when I process 0 and 0 using the net function. So it is correctly classified. We can conclude that it is correctly classified because it matches with the truth table. So our learning rate weights are properly classifying the given sample. So we can proceed with 0.2, 0.2 minus 0.3 as bias. Alright, the same thing can be proceed, and we will check whether the next iteration will give us the correct classifying values or not. So let me take with 0 and 1. If it is 0 and 1, according to the truth table, the value should be 1. Let us check whether it works or not. So similarly, first we have to find the net value. So net is nothing but W1 x1 plus W2 x2 plus B. So what is W1 value? Already we have the value as 0.2 and W2 is also 0.2. We take W1 as 0.2 into x1 is nothing but it is 0. And W2 is 0.2 into x2 is 1. Plus what is the bias value? It is minus 0.3 as given in the question. We are directly applying it, that's it. So it is 0 plus 0.2 minus 0.3. Now I'll get minus 0.1. So now I have got minus 0.1 as the net value. I'll check the activation function now. What is the activation function? How it will be activated? If the net value is greater than or equal to 0, 1 will be activated. Otherwise 0 will be activated. Now the net value is a negative. So if it is negative, obviously we will go with the otherwise case, it is 0. Now the answer is 0. The final classification is 0. Now we'll check 0, 1 in the truth table. It is 1 actually, but here we have got 0 value. So it is, we can conclude it as it is misclassified. It is wrongly classified. We are not getting the right answer. So what we have to do, we have to adjust the values of weights and we have to make it the correct classification. That is the major thing which we have to do. Well, so if I want to correct it, what I should do? I have x1 value. What is the x1 value here? It is 0, right? 0 and 1. We are passing for 0 and 1. So x1 is 0 and x2 is 1. We know this. Now we have to calculate the new weights. What is the formula that can be used for calculating the new weights and bias? We have here, right? So for new weights, I have to use Wi, the old weight, plus the learning rate of t minus y into x. This is the formula which I should apply on it. So now, what is the previous weight that I have used here? Let us take it. W1, right? For W1, the previous weight is 0.2. I have used a 0.2, right? That is the previous weight. What is the previous weight given? W1 is 0.2 and W2 is 0.2. That was what I have used in the previous iteration. So directly we can go with W1 as 0.2. That is the old weight, right? Check the formula. This is the old weight plus the learning rate. What is the learning rate? It is given 0.1. This learning rate is used whenever we want to correct the weights. When we face the misclassification and we want to correct it, we'll use this learning rate. So the learning rate already given is 0.1. We can use it here. So it is plus 0.1. Right. And what is the next parameter? It is multiplied with t minus y into xi. So I'll take t minus y into xi. T minus y into xi. So what is the value of xi here? X1, right? We are calculating for 1. So xi is nothing but x1. X1 is 0 here. Because we are calculating for 0, 1. So x1 and x2 here. So x1 is 0. Now, I have to fix with this t minus y value. Let me take t value is 1 and y value is 0. Clear? So because already we have the misclassified value y as 0 here in the previous iteration, we can take as it is and t equals 1. Because if I make t as 0, then the whole parameter will be 0. So for the safer side, I'll keep t equals 1 and check whether it correctly classifies the given data or not. So 0.2 plus 0.1. So if I do t minus y, then t minus y equals nothing but 1 minus 0, right? 1 minus 0 is 1. So this 1 minus 0 into 0. So we take the 0.2 plus 0.1 into 1 into 0 is nothing but 0.2. So now the W1 value is 0.2. Similarly, we have to find the new weight for W2. For W2 also, we have to apply the formula. So what is the formula that we should apply? For new weights, old weight plus learning rate into t minus y into the x2 value. So what is the x2 value here? It is 1. Why it is 1? Because we are calculating still for 0, 1. It's misclassified. We are trying to make it learn and correct the misclassified value. So we are adjusting the weights. So we are assigning new values for it. So for the weights, the previous weight which we have used is again 0.2. W2 is nothing but the previous weight is 0.2, right? That's what we have used here. The previous weight is 0.2. That's what I have given here, 0.2. The old weight less. What is the next step I should do? The learning rate into t minus y. What is the learning rate? It is 0.1. T minus y. T minus y is nothing but 1 minus 0, right? 1 minus 0 into x2 value. What is x2 value here? It is 1. So that should be used here into 1. So if I calculate this, I will get a 0.2. 1 into 1, it's nothing but 0.2 plus 0.1 gives you 0.3. So W2 is nothing but 0.3. So I calculated the weight 1 and weight 2. Now I have to check with the bias. So the bias value, to find the new bias value, I have the formula, learning rule. The old bias plus the learning rate into t minus y. Old bias plus learning rate. What is the old bias we have used? So the old bias is minus 0.3. So we'll check minus 0.3 old bias plus learning rate. What is the learning rate we have used? Learning rate is 0.1. Already we have used 0.1. So 0.1 into what is the next step? T minus y, right? So T minus y is nothing but 1 minus 0 as we have raised. So minus 0.3 plus 0.1 into 1 is nothing but minus 0.3. So the bias value was, sorry, minus 0.3 plus 0.1, it is minus 0.2. So the bias value is minus 0.2. So if I use W1 into x1 plus w2 into x2 plus b. Now check the value of this for 0, 1. That's what we have already misclassified. 0, 1 is misclassified. So now we have adjusted the weights. What is the new weight we have in w1? It is 0.2. So we'll apply it as 0.2 into 0 x1 plus the new weight w2 is 0.3. So we have 0.3 into x2 is 1 plus minus 0.2. Right, this is the value. So 0.2 plus 0.3 minus 0.2. We have 0.5 minus 0.2. It is nothing but positive 0.3. Right, answer is 0.3. So it is positive. So if I check here, so if it is positive, then the value should be 1. If it is negative, then the value is 0. So now, since it is positive value, we can make it as the result, classifying result as 1. Right? The function of net gives you the value of 1. So now check the truth table, 0, 1 is 1. Right? Now we got the right value. So we have adjusted the weights. This adjustment should be done only after completing the entire truth table calculations. Right? So this is how I have to adjust the weights if the classification went wrong. Right? First you have to process all the values with the previous first iteration values of learning rate, bias, weight 1 and weight 2. See, for example, this is misclassified, right? I have to calculate 1, 0. First, I have to calculate all the values of this and then I'll conclude which one is misclassified actually. Then only I'll go for modifying the weights. Right? For your easy understanding, I have to proceed immediately after finding the misclassified results. Once after done with all the four values, it will conclude that 0 and 1 is misclassified, and then only it will go for adjusting the weights and moving for the new weights and new bias value and new learning rule. Right, in that sense, if I haven't adjusted the weights, what is the weight that we have already used? 0.2, and W2 is 0.2, learning rate is 0.1, bias is minus 0.3. Am I right? This is the value which is already given for us, minus 0.3 minus 0.3. So if this is the case, I haven't adjusted the weights because I'm going to see the misclassification only after iterating all the four values of the truth table. So in that sense, the next step which I have to do is 1 comma 0. So 1 comma 0, if I use what is the net value? W1 x1 plus W2 x2 plus. So what is W1 and x1 here? 0.2 into 1 plus W2 is 0.2 into x2 is 0 minus 0.3. In this case, plus 0 minus 0.3, it's nothing but 0.2 minus 0.3 is 0.1. So here I'll get the value as negative. So if it is negative, according to the net function, right, we will get 0. So now we will check the truth table for 1 comma 0. For 1 comma 0, the truth value is 1, right? The result is 1. It should be 1. But we have got the value as 0 net. The function of net gives us the value of 0. So in that case, it is also misclassified. And what is the next value we have? 1 and 1. So now the net is nothing but W1 x1 plus W2 x2 plus E. So what is the normal value? W is 0.1 and W2 is 0.2 into x1 is 1, right? Plus W2 is 0.2 and x2 is also 1. Plus bias is minus 0.3. In this case, 0.2 plus 0.2 minus 0.3 is something but 0.4 minus 0.3 gives you 0.1. So this gives you the classification. If I compare this with f of net, the function of net tells you if it is positive then the value is 1. Wait, greater than 0 then it is 1. So now it is correctly classified. So this is correctly classified because in the truth table 1 and 1 is 1 and 1 is nothing but it's again 1. So now the misclassification actually involves 0 and 0, 1 and 1 are correctly classified. And 0 and 1, 1 and 0, these two are misclassified. So this is the problem here. So now if I want to make this misclassified, we have to make it the misclassification into the rightly classified model. So in that case, we have to use this weights, bias, everything. We have to adjust it using the learning rule. This is the learning rule, and these two are the formula which you have to use in order to calculate the new weights and new bias, right? And the learning rate will be used whenever you are moving for the learning rule. Similarly, I have done for 0, 1. Similarly, you can do it for 1, 0 with the same weights and bias which we have used for 0 and 1. For 0 and 1, we have adjusted the weights, and the new weight which we have got from it is, here we have W1 equals 0.2, W2 equals 0.3 and B equals minus 0.2. These three values can be again used in the making the misclassification of 1, 0 as like what we have for 0 and 1, and you can make it in the right classification model. This is how a single layer perceptron will use an OR gate in order to make the learning process in the neurons correctly. So for instance, if you are asked to pick up a pen from the table, where a pen and a chalk is actually placed on the table. If you have taken the chalk wrongly, then you will learn that it is the wrong information, and the chalk is not the pen, right? By seeing and analyzing all the features of the chalk, your brain will store that this is not the pen, right? That is nothing but the misclassification, and then the weights will be adjusted. So if it is a cylinder in shape, and if it doesn't have the sharp edges, then it is not the pen. So that's how some features, the weights can be adjusted. Weights and bias can be adjusted for that learning, and the new weights and new bias will be used in order to identify that the right pen. And next time when I ask you to pick up a pen from the table where a chalk and pen is placed, you will take the pen correctly, because the learning rate have adjusted its weight, and that have been stored in your mind that the other thing is not a pen. Alright, that is the basic concept behind this single layer perceptron. Thank you.